Hi, my name is Michael Richardson. I'm one of the authors of RFC 8995, but I'm going to be talking a little bit about implementation of RFC 8994, which is the autonomic control plane. I have some other videos about what is the ACP and how does it work, but this is about my implementation, which is known as Hermes Connect. So, topology we're going to look at is a 3-node ACP. The nodes are called Hermes, Moira, and Ovid. Those names are taken from Greek antiquity, and in this thing you'll see Hermes is in purple, Moira is in green, and Ovid is in red. And this video actually won't get to using Ovid at all, really. So they're connected up as shown in this diagram, and essentially have a LAN between it, and for some convenience there is the IPv6 trailing 4 digits of each node listed there, but that won't be actually very relevant, as we're going to see. Great. So let me just move that out of the screen, and let's look at what's going on. So we have here 2 windows for Hermes, and in this window we have a process that is basically tailing a few logs that we can look at them and see what's going on. So first of all, I'm just going to start the process. I have a little script to do this, and it does a few things, and I'll talk about what that is in a moment here. So first of all, what does it do? It scans through all the interfaces, looks at what they are, and you'll see that it found an interface called IETF, which was a bridge, and it created a new Ethernet pair for that one. And then it found another interface which is known as trusted, which is my working LAN where I have all my trusted computers, and I created a new Ethernet pair for that. So let's just look at how this looks like. So if we look at them at our basic thing, we see that we have some new interfaces here, pull, parent, dull, and we have 2 of these there. And what's happened is that they have been added to the there's 2 bridges on this machine. The IETF one is connected to the IETF Hackathon VPN, and that's basically the host system, what's going on. So let's look into what's underneath the covers here. So now I'm looking in the dull network namespace, and you'll see that it looks very different. There's a different set of interfaces, a different loopback interface, some this IPv6 VTI that's there, and they have different index numbers as well. And you'll see there's this dull interface, which is actually connected to this interface. They are essentially a set of pipes between them. And also this interface is connected to this one. So it's automatically done that. If it had found an ETH0 that wasn't connected to a bridge, it would have made a MAC VLAN. The 2 can't be created at the same time. So what else is happening in here? So it doesn't have its own process ID space, and it doesn't have its own user ID space, just network address space. So there's that part only. So I'm just going to exit this. So let's look in the ACP network address space. So again, it's a different one. It doesn't have anything. It just has a loopback and the other 2 pieces. It's pretty boring that way. At least for now, it's pretty boring. So we're going to come out of there and leave that. We're going to go into this machine that's called Moira, which is a second machine with the same software, and I'm going to start the daemon as well. Now this device does not have the same IETF network. It's only got the one, so it's only created this pull 4 attached to this there. And if we look inside the dull, then we will see also one interface only inside there. And in the ACP space, again, we have only the single one. Well, a little bit more happened, and you may have noticed this happened here. You'll see that there is now this ACP interface. It's a point-to-point interface, and it has some stuff here. It has a tunnel from here to there. So what happened here? When things came up, it created a new, it found a new interface, and it saw a new peer, and it created a new ACP interface, 01 with index 4, and it moved it to this this network namespace, and that's what we saw there. Then it did something else. It added a new connection with this name, and that name is deterministic, and it opened up a new IPsec connection. And over here, there's actually a dump of what's going on in things, and I can just move my head out down here so you can see it. And what we're seeing right now is the grasp messages on 7017, but we also saw back here, we see some ESP messages, and we also see that negotiation that happened, that IPsec tunnel coming up for that. So that all happened autonomically, to be precise. And every couple of, every 30 seconds, we get a list of what's up or down, and the statistic doesn't yet know the tunnel is up. So let's look over here. So we look into the ACP on this one, and we'll also see here an ACP interface here, and we can do something. So let's go look at this interface, grab this address, okay, and paste it over here, and then say I want to put my traffic through ACP there. Now, life is not perfect, and it doesn't yet all work. So what's supposed to happen is you'll see an ESP packet going through, and you would see a ping reply. So everything is not quite debugged at this point, but that's the theory. So let me try it the other way. Sometimes it works the other way. The important thing is that I have these are link layer addresses, and so they're very particular about that. So you saw that there was an ESP packet going in one direction, and for some reason there isn't an ESP packet going the other direction. So what's happened, and this is a part of the bug that we're looking at, is there's probably still lingering IPsec state in the kernel that didn't get cleared completely, and therefore it's in fact going out the wrong direction. So that's the state of today. We have a third machine here, and when I bring the third machine up, bad things happen. So for fun, let's do that and see what happens. So it notices things. You see that they noticed another connection there. You see that the IPsec, it tried to bring it up, and lo and behold, we have a third network that's going. And now actually each machine now has two peers, because it has the other two. It should have noticed both of them. Can we ping it? Can it work? I don't know, but we could try. At this point, it's pretty much crapshoot as to what's going on. So it says address unreachable. So it really is not. It really doesn't agree with us at this point at all. Let's try this one. That didn't work, although we do get some ESP packets happening at the same time, which says that something's going on here. But at this point, it's not really working. Thanks for tuning in, and watch my other videos for more information about ACP.